Okay, now it's started. Okay, now I can
Now it's
start. Yeah. So Russ has kind of introduced me. I'm also a Microsoft MVP data platform. You may have known that as SQL Server, but now all things Microsoft are more than SQL Server in the data platform. I go by Data Chick on most social media. That has a long story behind it. I am certified as an Azure data engineer. I'm also a Microsoft certified trainer, and I'm also a NASA data naut. And if you ever want to talk about space data, open data, or the NASA Space Apps Challenge, which just finished last weekend. So I have been trying to recruit people from the data platform SQL Server world to start entering these chats. So if you go to Space Apps Challenge, the NASA Space Apps Challenge, you'll find that it's the world's largest global hackathon. This past weekend, we had participants from more than 150 countries, and it's all free to enter. It's a weekend long thing anywhere in the world. There's both in-person and virtual events. And the great thing about it, it's not all the challenges are about code. So don't let the word hackathon get you thinking maybe you don't want to write an application on a weekend. You don't have to. So the whole focus of the Space Apps Challenge and why I'm telling you about it is all the challenges involve using NASA or other space agency open data. And there are art challenges. There was one to design a travel agency for when oh, there goes my personal assistant. Hey Alexa, do not disturb. Now don't you guys be talking to her. See, it's already enabled and she still interrupted me. Alexa, set your volume to 1. She's a personal assistant who can also get on your nerves, just like a human one. Um, and now she's mad at me. So anyway, I always try to promote these NASA things because I'm such a space fan, as Russ noticed. Um, so one of the things I'd like for you to take away is this is my mantra. As an architect, as a data evangelist, every design decision comes down to cost, benefit, and risk. Oh, someone's got their hand up. Is that on purpose? You'd have to come off mute if you have your hand up. Okay. I
Wonder if
will.
that was me.
No, it's well, there's an email or a name and a number, not a name. Anyway, I'll let you take care of that. And then if someone comes off, oh, the other thing I wanted to say, please don't save your questions to the end. I love engagement and interruptions. And even if you have a question or a comment or would like for me to cover something again, just let me know. And I can see the messages in chat. So you could also ask questions in chat. So why this topic? I want everyone to love their data. My hashtag is team data because I want you to be on team data. That just means I want you all to be data evangelists as well. So I have one of these nifty Slido things where you can go to slido.com, type in that number, and tell me what your primary role is. And what I want here is not your title, not your current job role necessarily, but what's in your heart of hearts, what your mama raised you to be in the data world, or even if you're not in the data world, I'd love for you to fill this out. So I'll give you a few minutes to go to that. You can go to that on any device. You can use the QR code, but I find it easier just to go to slido.com. Oh, I think I saw some numbers change. Did some numbers change? There we go. Look at that. Yay, data architect engineer. So anyone who voted other, I'd love to hear, either you can put in chat or come off mute and tell me what other is. There's more than what's just in this list. The slide just shows you this many. And no managers. I made all these pictures in this slide deck just for managers. Okay. So when I say database designer, when I say this topic is a database designer's favorite security and privacy features, I'm kind of meaning data architects, data modelers, a development DBA, sometimes it's called, accidental DBAs, people who are responsible for determining what the tables and columns and other features that help make the data better data, and not necessarily the people responsible for networking and backups and restores, even though that's an important part. It's just, I'm saying these are features inside a database that deal with security and privacy. So the next thing I want to know, here are some ones that I gave this presentation last night and decided not to wipe out the previous audience's responses. But if you could go on here, go back to Slido and tell me what security issues keep you up at night. And you can retype the same answers as well if you want. Russ, I think that there's a thing in chat just for you. Passwords. Passwords keep you up at night? Like, do you dream about passwords, password policies, people sharing passwords, people writing passwords on the whiteboard? Also a thing.
Changing
Yeah.
passwords, mostly keeping track of passwords.
So you mean like system passwords and things like
Yes,
that, or your
system
own personal
passwords,
ones?
personal passwords.
Yeah. So do you use a
What's sufficiently
password?
strong?
Yeah.
How can you remember them? What,
Yeah. So I
et
never
cetera, et
remember
cetera.
my passwords. I'm totally sold on secure password managers. And I have learned that gives me extra horrible to type passwords that are really long that I can use everywhere. So that's how I keep, and I never reuse a password either. Well,
Do
that's
you
not
keep
true.
them on? Is there an app to do that on your phone?
Yes. And so what I use have used both 1Password and I currently use Dashlane as well. I used to be a LastPass users, but long before their third data breach and hack of the passwords, they did something once at a client site with a team account that I felt violated all security rules. So I moved away from LastPass, and finally that organization moved away from LastPass after their recent data breaches. But there are professionally managed password keepers that allow you to have very long, and therefore I almost never type my password, nor do I know what they are. I don't memorize them. I also use biometrics to help as an additional thing to protect those passwords. That's where I am. Privacy and authentication, that's a good one. Well, somebody who shouldn't get access to my data and cause harm. Yeah, that one does it for me too. And my current things, given some current roles while I am fearful of external entities hacking in, my current pain points are inside people doing silly things with the data they have access to. So that's what's keeping me up at night is, people, like I had a case recently, I won't tell you the client, but a person was contacted on LinkedIn to get some of the people, um, hey Monty, what's going on? Are people there for the in-person meeting? I think that's what's happening, Ross. I think that's why they're sharing their screen.
Yeah, I see that. And I sent out an email and told them that, told everybody that was going to the in-person one that it was canceled. But
Maybe Monty could share that with the people standing there. But Monty's on mute, so I can't see. I don't know if he can hear us.
Hi, can you hear me now?
Yep.
I sure can.
No.
Yeah. Hi,
So
Monty.
hello guys. We've been here in the lobby for an excess of 15 minutes now. There's a group of us down here, but you're saying that we're in error. None of us received an email. So do advise.
Yeah, and I apologize for that. I had We, the venue was, the on-premise meeting was canceled because, we don't have a venue. As our Microsoft sponsor couldn't make it tonight. So,
Oh, I
um,
see.
so that's,
Excellent.
that's the issue. Well, not so much. And,
All right.
I
Yeah.
really
So
apologize.
none of us had an email. It's okay, but we were here. Thank you for your time and for
Yeah. And thank you
uh,
for showing up. That's really cool.
Yeah,
And
thank
I'm
you for
sorry
your
it didn't
time.
work out.
yeah, some of us drove a little bit, but it'll be all right. So anyway, guys, say goodbye to the team. Yeah. All right. Till next time, guys.
Thank you. Thank you for
Thank
helping.
you.
Okay, we got that sorted. My big thing is that I'm worrying about recently is insider people who don't understand that you can no longer have someone contact you on LinkedIn, ask you for some customer data, and send that customer data to them on LinkedIn, because there's a good chance that person on LinkedIn isn't the person they say they are. And you should not share PII via unsecured means. And as much of a fan as I am of LinkedIn, it is not a secure means for sharing sensitive or PI, personally identifiable information. So I also am worried about end users who do things when I thought we had trained them and everything. So that's another thing. Password leaks, I do worry about password leaks. I recently had to deal with someone whose account was compromised because they fell for a very smart phishing attack. And I'm worried that, well, I'm not worried. I know someday I'm going to fall for one as well. I'm not going to ask if you guys have ever fallen for one. It's just like a data breach. I keep telling my clients it's not if, it's when. And I recently worked with a software vendor who was in the news because of state actors hacked their software distribution system and therefore compromised a whole bunch of their software clients. I know you guys probably might know who that was. And that was really like my chance of protecting myself from foreign actors who have millions and millions of dollars who might want to hack my customer list. I'll just try to do all the things I can do to protect my assets. So thank you for sharing those with me. The other thing I want to talk about, and I just want to say I was totally lucky that I predicted this. I've been saying this for like 10 years. So for decades, our number one vulnerability and cause of data breaches was SQL injection. And if you work in the database world now and you don't know what SQL injection is, please go read up on it. For decades, it's been the number one reason. Little Bobby tables. If you don't know what little Bobby tables are, you need to go search for that as well, because it's one of the oldest security memes in the world, and it's still brilliant every time I read it. But I predicted with the advent of cloud storage that SQL, oh, and I want to go on my usual rant about SQL injection. SQL injection, something we know how to test for. There are tools for testing it. There are tools in Azure for testing web apps for SQL injection in code. Um, we know what causes it. We know the best way to send queries to a database to protect from it. And yet, for decades, it was still our number one cause of data breaches. And then sometime around 2021, it fell to number 3, because as I had predicted, the number one data breach are going to be what I call open buckets. Like an S3 bucket in Amazon, where people put a database backup just to hold it there because they wanted to share it with someone, and they didn't bother securing it because the guy was supposed to grab it and then let him know, and then they delete it, but they never got around to deleting it, or it was up there just long enough to get detected. That is what broken access controls it refers to primarily, is people putting sensitive data or any data up in Dropbox, Azure Blob Storage, or S3 buckets and leaving them totally unprotected. And that in 2021 became the number one thing. So, you can put all the access controls and security, but if someone's allowed to export all the data from your database and put it anywhere, it doesn't matter what controls you have on your application and database because a person has broken it. And this is where I just put in my usual rant. I'm a data modeler at heart. It's what my mama raised me to be. And my preference is we start documenting security and privacy requirements at requirements time. It's not something that you apply in an application or when you build a database. We should understand the data. And I have to apologize for showing a table as a data model and not as DDL to this group, but that's how I talk about design. And, we just need to be able to talk about gathering the requirements from business people, from data architects, from data engineers, from the security people, from the lawyers, and we can tackle the business requirements in our data models. The other thing I want to throw out, just as an aside, I also believe data quality. So again, team data. I don't want data to just be fast. I want data to be correct. So data quality is also data security. So I'll show this example. This photo comes from a poem available on the internet in many blogs called Ode to a Shipping Label. And it's a great poem written by a person who got a shipping label that looked like this. Now, this is not my photo, and the reason I say that is that L amp amp a tilde amp amp sup 3 pez actually spells Lopez, which is also my last name. And that has happened because Lopez usually is spelled with an O with an accent over it. And somehow, as this shipping label was presented, it had data that was probably collected in a point of sale, maybe on a website, sent to a back end. That data got escaped and an ampersand and a tilde, and then that data got escaped. And finally, after it got from the distribution center to this UPS label, Lopez became that, and the person still received the shipment, which I think is amazing. But it doesn't matter how much you protect the database if you're still allowing the data to be tampered with or messed with, because to me, this is also a security issue because we've changed data in a way that the business didn't ask for. That's my rant. And then my final rant thing as this introductory thing is everyone knows what ROI stands for, right? Return on investment. But if you're having trouble with executives and managers or maybe developers agreeing to the security design features I'm going to talk about, you have to tell them about the new definition of ROI, which is risk of incarceration. Risk of incarceration, most of the modern privacy and compliance legislation that's coming out has not only civil penalties for data breaches or privacy things, but also criminal charges. And as we've learned from a lot of compliance issues, it's typically not the CEO or the CIO that goes to prison when people aren't following compliance. It's going to be the managers and the supervisors, the team leaders, and the DBAs who might have to pay criminal penalties, like serve time in prison, if there was a data breach because the data wasn't properly secured. I hope that puts enough fear in your guys and also allows you to go talk to your director or your CIO and tell them you're working hard on ROI to mitigate their risk of incarceration. So let's get on to the real gist of all this. I call this security in the DDL. That's just sort of a joke on, I'm talking about security and privacy features inside of SQL Server and Azure SQL DB. This is brand new stuff. It's so new. These features that I'm about to talk about were introduced in SQL 2016, which has been a while. So we're going to talk about always encrypted dynamic data masking and row level security. And one of the things I found is most of the DBAs I work with, they're production DBAs or operational DBAs. That means that, yes, they love their data, but they really love databases, and they know that tables exist, but not so much what every column means, how that data, what it really means, what its risks are, why is it collected, what is it used for. I mean, I know some DBAs know this stuff, but most are dealing with performance issues in queries, um, uptime of servers, latency, people hacking a database. But I'd be interesting to know in the chat if you think that most operational DBAs actually are experts in all the columns, in all the tables, in the databases they support. So the first feature I'm going to talk about, always encrypted, very quickly. It's one of my favorite new features. And when I say new, 2016. And always encrypted is exactly that. It was a feature introduced that works with a certain .NET module or component, a library component that encrypts the data from the database across the network and to the client. And the client could be an application, Excel, Power BI, a website. What's happening is there are two keys, one a column master key and one a column encryption key, and you must have access to both of those to see decrypted data. So in this example, we have a very simple patients table that has a name, a social security number, and a country, and you can see in this conceptual diagram that the social security number has been encrypted in the database. That's encrypted for everyone. Even if you were a DBA with DB owner and you ran a select star on this table in SQL Server Management Studio, you would see encrypted data unless you were accessing that table via this .NET library component and you had access, you had the master key installed on whatever client you were using, and you also had availability of the column encryption key. What does this solve? Oh, one other thing I want to point out that's really important about this. You'll notice that the query itself is also encrypted. It's not the logic in the query that we're worried about. We're worried about data items in the parameters in a query. So if you're searching for a patient with this social security number, your query has personally identifiable information in it. And therefore, the query itself gets encrypted. And the whole reason for the security thing is to mitigate man-in-the-middle attacks. Man-in-the-middle attacks usually happen because we had encryption on our storage device, encryption like TDE in SQL Server, but those encryptions only encrypt the data at rest. As soon as SQL Server coughs off that data, those older traditional encryption things, it's unencrypted. So what would typically happen is that SQL Server would offer up, or any database would offer up the unencrypted values, and then it's somewhere in the middle between that data leaving the SQL Server and going to the client application. It would have to be re-encrypted over the network. If you remember, the big Target breach was a man-in-the-middle attack that got to the data between the point of sale and the credit card reader, because the data was in they were sniffing the data. They had installed malware to sniff the data while it was unencrypted between those things. So it's a feature embedded into SQL Server and Azure DB, but it does require this .NET component. So if your application doesn't use this .NET framework thing, you can't implement always encrypted. And because it involves these multiple moving parts, two keys and the .NET component, you can't just make this a property of a column. You do it in SQL Server Management Studio or in code to set all these things up. And Management Studio, I recommend this for people who are starting to use it or want to learn it, because while we don't use GUIs at scale a lot, it helps you understand, and it will gut check, your availability, all the constraints on it, to see if you can do that. So you can see in this screenshot, we have set up encryption on SSN and credit card number. There's a lot more details into the type of encryption, deterministic or randomized. and then what encryption keys. And you can use a different encryption key for each column. You can use the same one. It all depends on what your requirements are. So the key takeaways here are that always encrypted is enabled at the column level. It's not at the table. I mean, certainly you can encrypt all the columns in a table, but you implement this on a column by column label. And because it's always encrypted, it protects the data at rest and in memory and all the way to the client. And you need these two keys. You can use Azure managed keys like in Key Vault. You can use your own keys. So if you're a DDL person, you can see that in this screenshot that I swiped from Microsoft Learn, that you create the column master key, you tell it what encryption algorithm, they're limited on what encryption algorithms you can use and what the encryption key is. And then you create your table, and you create your table with normal things, and you say that the column is encrypted with this column encryption key, the type deterministic or random, and what algorithm it uses. And the same thing for SSN. And one of the funny things I'd love to point out here is every database sample in the world does something terribly wrong in their database design. And in this particular one, you notice in their customer table, they have a column called age. Well, what's the trade-off if you put age, if you track age in your customers by a value? Is that every year you have to figure out when to update it to the next value. So, I have to point this out as a database designer that a much better column here would be date of birth, along with the time zone of the date of birth. Just throwing that out there. So some other takeaways are if you use always encrypted on a column, if you're encrypting a primary key, then the foreign key must match the same encryption setup. Otherwise, they won't link up. And of course, your code needs to support that particular .NET version. Why would a database designer love it? It's always encrypted. Helps solve for that man in the middle. It also allows someone like a data architect, someone who understands the data and how it's used, how to configure that encryption. It doesn't leave it up to someone who doesn't understand the data to do it. The parameters in your query are encrypted as well, and it's built into the engine. So the theory is you could implement always encrypted in your database, and as long as your application uses .NET, your business application doesn't have to have any changes in order to present the unencrypted data at the end to the client or the UI of the application. I know there can be exceptions here, but this is a way for data people to recommend encryption that doesn't involve getting developers to have to make a lot of changes to the database. Do we have any questions or comments about this particular topic? I'd love to see in chat if you've worked with this, tested it, seen a demo of it, more curious about it, any of those things. And we'll just sit here for a second. And also let me know. Oh, go ahead.
I have a comment, and not only do database designers love that, but auditors love that as well.
Encryption's always good.
Yeah, I like what you're saying about how the host variable is even encrypted, so you can't see it in the query.
Yep. I always love it when I see people sending out or putting things in a forum or responding to a blog post, and they've put a bunch of queries in asking for help, and they've actually shared a bunch of PII in the queries that they scraped from their application or their stored proc or something like that to put into a public forum, which is also a data breach, or can be, unless they've hidden the data. But yeah, that's the theory behind it. And most speakers don't point that out. I think it's really important. Okay, so we'll go on to the next thing, dynamic data masking. This is my favorite one, but Microsoft classifies this as a security feature, but that's also because all of their security and privacy features come under the security banner. I don't personally see it as true security, but I'll tell you why. So dynamic data masking is the typical thing. If you have a column called credit card number, and it's not encrypted because if it's not always encrypted, so always encryption is also a blocker to dynamic data masking. You have to choose one or the other. But it's very common to see something like credit card number. We don't want it showing up on a report. We don't want it printed on the receipt. We want to mask all the characters except for the last 4, and dynamic data masking will do that. So some examples. First one, if you see in a database, and let's say the column name is 1, 2, 3, 4, but if you see a bunch of values that are 16 characters wide, that always start or tend to start with 1, 2, 3, 4, 5, or 6, you kind of guess that that's a credit card number, especially if it's in a table related to payments or something. I'm going to guess it's a credit card number. So dynamic data masking allows a database designer to say, this is the mask for this column. Every time that column is returned, this is how we want it masked. Another example, this actually says Karen at infoadvisors.com. You just can't tell that because I've put an email mask on it. You can see that this 99,009, number is a mask because I'll show you how that works. You can see this incorrect date of June 99, 99999, and you can see KXXXX Lopez, and I'm here to tell you that's my twin brother's name, Kenneth, not Karen. But okay, you wouldn't have guessed that because it's masked. So the most important thing about takeaway for dynamic data masking, the data in the database itself is not masked. This is not on the stored data. If you go to the table and you have the right permissions, you'll see the regular data that I just divulged to you here, that says Kenneth Lopez. Dynamic data masking allows a database designer to say, hey, SQL Server, once you've run the query, done all the work, once you return the credit card number, you're going to mask it this way with every character except for the last 4 replaced by X's and only show the last 4 digits. And we'll talk about why that's important. So this is what the DDL looks like. There can be a table, has a member ID, it's an identity, it's primary and clustered key. But for first name, we're going to mask it with a function that looks like partial 1 XXX1. Partial means it's a custom mask for a character field. And this particular one says, show me the first, for first name, show me the first character, fill it out with X's, and show me the last character. That's a custom one. For last name's not masked here. Phone number is masked with the default. Default in dynamic data masking is based on the data type, and I have a slide about that later. Email is a specific function that masks emails in a specific way. You can see discount code is a small int, and for numeric data types, you can say show it as a random number between 1 and 100. And birthday is a date time data type, and we've said mask it as the default. So between 2016 and 2022, SQL Server 2016 and 2022, they have added a date time mask as well, and my slides aren't up to date. Dynamic data masking, it's not encryption, it's not a security feature, because your data at rest in your database is not masked. That's the most important thing here. If you were to take a certification quiz, I can guarantee you they're going to ask you something about the fact that data on the disk, data in the table is not masked. It's done after all the SQL Server work and as it presents the results from that column. So I say it's not a security feature because of that. If no one's running any queries against your database right now, there's no masking. It's meant to complement other methods. And because it's performed at the very end of your query, it has almost no impact on performance. And this is one of the reasons why I think it's really important, because this is one of the, it's not truly free, but I like to say it's like free, because it's an enhancement to the privacy of the data, protecting the data that has almost no performance impacts. So there are 5 functions available today. Sorry, I didn't update my slide. Every data type has a separate default. I'll show that in the next slide. There's an email mask, a custom mask, and a random mask, plus the date time one. The default for a string is to replace all the values as X's. For numbers is to set it to 0. For date and times to set it to this January 1st, 2000, 000 date time. And for what I call flags for binaries, they're all set to 0. Email gives you the first character of the email, then X's, then .com, always .com. So that email says Karen@infoadvisors.com. You just can't tell. And for custom, an example is you just get to do whatever you want with those patterns. And there are a bunch of parameters you can do. You could set, everything to A's if you wanted, or emojis, I don't know. And random is only for numeric types, and you give it a range. So the data in the database isn't changed, but ad hoc queries can expose the data. So for instance, I could have data masking set on salary. So let's say it's employee salary column. I could, if I have access to do ad hoc queries, I could totally write a query that said, show me all the employees with a salary of $160,000. And it would return all the rows where employees had that as their salary. It would present the salary. Let's say I set it to the default to 0, but it's going to answer my question. Another way that these ad hoc queries can figure out information is you can do things like force a divide by 0. You can, just ask for you can still ask for aggregate things like the highest paid employees. So that's why I think it's not really security, it's just privacy protecting. And so typically, if you put dynamic data masking on a column, you also don't allow ad hoc queries or connecting it, to Excel so that people can run their own queries, because you could totally guess the values based on an ad hoc query. It applies when you're exporting the data. There's a blocker that you can't mask encrypted columns because it's already encrypted, and it wouldn't make sense to put a mask on an encrypted column either, because it now doesn't have the same data type because it's an encrypted column. It can't be configured on a computed column, but if you have a computed column that also has mask data, it will compute on that mask data. It also protects select into or export data, any access to the data. So the thing that's new in 2022 here is that it used to be that it applied to dynamic data masking applied to a whole column. That's the specific columns, but you can add unmasked permissions to people based on a column, a table, a database, or a schema. So for example, if you had a supervisor in the call center where the call center people only got to see the last 2 digits of the Social Security number or the last 4 of the credit card number, now you can give the supervisor permissions just to see the full credit card number. And before this change, you had to give someone the right to unmask all data or no data, and now you can apply it at these different scopes. Why would a database designer love it? What I love about it is that I, as the data expert, the data architect, I know that the PCI compliant way to mask a credit card is all but the last 4. I might also know that GDPR requires masking of certain things this way and doesn't support masking of it another way. This relieves developers and production DBAs from having to go do that work. And it also engineers out the issue of we'll worry about masking in the next release because we get to do it right from the beginning. Any questions about dynamic data masking? You can always put those in the chat and ask them by coming off mute. I'm not offended by people coming off mute. So there we go. So my next favorite one, row level security. It is just that. It allows you to use parameters to drive the fact that a user or a group of users who fit parameters can only see certain rows. So it's based on values in those roles. in those rows. And the typical example is used. Medical professionals should only be able to see the data of their patients. Salespeople should only be see the data of the customers in their region, those types of things. So traditionally in the old days, the way we approach this is we either created a view for each salesperson that had only California customers and we gave them access to that view, or we rolled our own security policy right in the application. So row-level security filters the results based on these predicates. The predicates are applied while reading the data. This is for queries. But the other thing that people don't realize a lot about row-level security, it also protects write updates. So you wouldn't be able to have like a salesperson go in and change the data of customers that aren't assigned to them. So I consider that a nice feature as well. The other key thing here is that the end user gets no indication that the data has been filtered. If I only see customers in Canada and I do a query of all customers, I'll just see that the database has only Canadian customers. I won't know that there are customers in California or New York or Germany. If I say, show me, if I only have access to customers in Canada and I say, show me all the customers with California as their state in the state column, I'll just get, there are no customers. I won't get, you can't see the California customers. So there's no indication that has happened. And this works for even DBO or database owner roles. So why would a database designer love it? It allows a designer to do this data protection based on data right in the database. So like I said, in the olden days, we made views that applied these filters, and that meant we had a lot of views to manage just to do row level security. It also meant that we tried to do it in the application, but the problem is we know in 2023, people want to have or can have other ways of accessing the data, either self-serve BI or, you know, Excel or other, and, you know, and the days of having one database per application or one application per database are long gone. So this allows us to do it right in the database, and then it's enforced every time someone accesses the database. Any questions about that? Anyone have another way that you guys have implemented row level security before? Oh,
Well,
I had one. Yeah, go ahead.
We got a question here.
Okay.
Steve Clark is asking, which SQL versions support this?
So row level security was introduced in 2016, if that helps you. So, oh wait, do I have that wrong? No, I think, oh.
I think that's right, but
I think that's what I said. Yeah, it's the first three. Yeah, for sure. Row level security.
But it's, how about the one where you can apply it to an entire database or table?
Well, so row level security is at the table level.
Mm-hmm.
So are you thinking about something else?
Yeah, maybe I am. Can you go back a slide?
More? Oops,
yeah, another one.
Oh, sorry. I must have sticky fingers. So are you thinking about the dynamic data masking one?
Yeah, that one.
Okay. So this is about permissions to unmask data.
Oh, okay. All right.
Right. So it used to be you had to give people mask or unmask rights in general. Like you give your DBA unmask rights so they could figure stuff out. Now you can give logins, unmasked data on a whole database, a whole schema, a whole table, or just specific columns. But row level security works row level security.
Gotcha.
Okay.
Thank you.
Yeah. So another key, how much more time do we have, Ross?
You got till 7:30.
Oh, well, it's way past. Oh, you're on Chicago time.
That's correct. Yeah. Well, yeah, I forgot we're in different time zones.
I'm looking at my time. I'm like, it's way past that. Okay, we're good. Thank you. But you can help me keep track of the time because I can't speak and chew gum and calculate time zones, even 1 hour off at the same time. So, okay.
Sure.
So I'd love to hear if any of you have used SQL Server Management Studio data classifications task. So you get to this, you right click on your database, you click on tasks, you click on data discovery and classification, and you ask it to classify your data. And I think this is one of the best kept secrets for a lot of people, especially if you don't regularly use SQL Server Management Studio. But what SQL Server does is it goes through your entire database and it makes a guess based on your key takeaway here, the name of the column, to see if it might be sensitive data. It supports several languages. I can't remember how many, but I think initially 6, but I might be wrong here. Now, I know all of you use brilliantly long and meaningful column names, right? Everybody nod their head. I can see you, even though your cameras are off, nodding your head. So in this particular example, it's seen something in a schema called human resources and table called employee and a column called DOB. So it's probably thinking that DOB stands for date of birth, and it's guessing that the information type for this is date of birth and that its sensitivity label is confidential GDPR, which is one of the built-in sensitivity labels. Well, that looks pretty good. And then it looks at person, address, city. It guesses that it's contact info and that it should be treated as confidential. It looks at something called a table called password with password hash and password salt, which I would not keep in a table myself, and guesses that those are credentials and that it should be treated as confidential. These are guesses that SQL Server is making, again, based on your long, beautiful, meaningful business names of your columns. Now, what you can do is you can say, hey, you got that wrong. DOB stands for dog owner's blouse color, and it's not confidential and it's not date of birth. So you could delete that or change it to another information type. But then what you can do is save or update and save. And in this particular case, in a database called Contoso HR, I went through a schema called data for a table called membership and said that these 3 columns, birthday, email, and first name, and I said, this is the information type, which is, by the way, a SQL Server guessed at, and what its sensitivity labels were. I think I messed with those. And now I have saved that inside SQL Server into the extended properties. And now anything that can access the metadata about our tables and columns can find out that we've applied these labels and information types there. So it means if your tool can see that, then it can see the classification and maybe take actions there. So this is a data governance thing. It helps you understand. But the reason you want to go through and do all this is when you run another service, such as vulnerability assessment, it can help make recommendations. Hey, you tagged email as confidential. Do you want to mask it? Do you want to encrypt it? Do you want to do any of these things? So someone doing the work of classifying all the tables, all the columns, can then help you help other tools make recommendations about these things. I've seen that sometimes there have been some security people that recommend you never classify data because anyone who'd hacked into your system could now easily find sensitive data and exploit it faster. But I'm here to tell you, the professional hackers have better data classification tools and scripts. They already know how to profile the data to go find out where your sensitive data is. So I still think the cost, benefit, and risk here, my mantra, applies, that being able to tag a column with the fact that it's PII or confidential is important for helping enforce these rules and for running vulnerability assessments. Having said all this, you can actually add your own information types and your own sensitivity labels in here. It's just SQL Server won't understand them, won't use them. It only uses the built-in ones. And if your column names are really terrible, it's going to do a worse job. And I know sometimes you support databases that an ISV created or a vendor created, and you don't have any control over their terrible column names. I get that. But still, this can really help. Any questions about data class? Anyone run the data classifications, even for fun? We're going to talk about later about why you should run these things, but I'm just curious. Or if you knew this was there and you didn't find it helpful, or you did, I'd love to hear that.
I didn't even know it was there.
Yeah, there's more too. It's the best kept secret, and it's been around for a long time. I don't know how long, but we'll talk about a better version of it too. See,
Yeah,
this is why I do this presentation, because I love talking about security and privacy and mitigating things. So this is brand new in 2022. It even came in a later version, like a CU, ledger databases and tables. So hate to say this, it's bringing blockchain-like technologies into SQL Server and Azure SQL Database. By the way, all the way through, I've been calling it SQL Server, unless there are some things that might only be available in Azure, but when I say SQL Server in this presentation, I mean both SQL Server and Azure SQL DB, the cloud version. Ledger tables are brand new. So there are two types of ledger tables in the new SQL Server. One is append only or updatable. So this is append only. And oh, I got to point out something other funny. When I do my PowerPoint slides and I use the designer stuff and PowerPoint guesses at a good icon for the word DBA, it chooses one of two things. This little dancer guy, the ribbon dancer, or a skeleton. And I have no idea. Maybe it's the PowerPoint product team that likes to make fun of DBAs that matches that up. Maybe it's an algorithm. I don't care. But now going forward for DBA, I've always used a little ribbon dancer or a skeleton, because what else are you going to use? Just a generic person icon? I don't know. I think it adds some fun, and I get to tell that story. So in SQL Server, you can have ledger tables or ledger database. When you create a database, if you mark the whole database as a ledger database, and by the way, this is full on SQL Server. It's not a different product. It's just when you go to deploy the database, if you've given that database the property of ledger database, all the tables in the databases will be ledger tables. They're still tables. They look like tables. They smell like tables. They have they have all the same properties as other tables. You query them exactly the same way. It's just, we'll see in the DDL next, has a different property to it. But an append-only ledger table says just that. You can't update the rows, you just append to it. So the typical use case here would be for a table tracking, let's say, sensor data. Let's say temperatures in a truck driving down the highway, and we're trying to monitor for the temperature not exceeding a value or not being below a minimum value. This is really common in logistics and distribution systems, and you never want anyone to tamper with that data. So you make it an append-only table, ledger table. And what happens when you say that a table is a ledger table is there are some additional columns added to it, which we'll see an example coming up, and some additional features. But the main thing that happens is when you create a ledger table or a ledger database full of ledger tables, is that there is a digest, the database ledger, that is kept separately outside of SQL Server, outside of the server the SQL Server server that keeps track of all the values, and the values are chained to each other with hashes of the value of the row, and that links that tables together. That's the underlying feature of blockchain, is that the blocks are connected together based on a hash of it. So if you change the data, the hash will change and the blockchain will fail, because the connection between the blocks is the hash of the values, and therefore it breaks because now the chain is broken because the hash changes that connects all the tables. And I have a whole another presentation about how ledger tables work. So I'm going over some things really quickly. The key is, see that big red line between the dancing ribbon guy DBA and the storage, is you totally would want separation of duties. You wouldn't want people who manage the database to have any access at all to this trusted storage. Oops, sorry. And that means that if someone is able, editing the hex values of the database storage files and is able to change the data, if they do so and don't have access to change the ledger, meaning sort of like a log, but a very special log of those tables, then when you try to verify that the data in the table matches the ledger, it's going to fail verification because someone has tampered with the data in a way that the database ledger doesn't know about. It used to be in blockchain and in ledger tables, we would say that they were tamper resistant. They still kind of are. We've just modified the language in the industry to say they're tamper evident. So, of course, someone in this type of scenario that had access, admin rights to the trusted storage, and the trusted storage was a certain type and had access to the database and the files underlying the database, they might be able to change both the ledger in a very sophisticated way and in the table. So this requires a separation of duties and access here. The other thing is there's a ledger view that automatically gets created in SQL Server. If I have time to get to some walkthroughs, I'll show you those. But basically what's happening here is there are special features added to SQL Server to support all this. Now, the recommended way, if you need a ledger table, if the data is so important that you have to make it tamper evident, this trusted storage wouldn't just be Azure Blob Storage, it would be confidential computing. So the confidential computing in Azure is a combination of hardware and software and OS that physically stops changes to the data. So it's a hardware layer and a software layer. It's not just software the way we've done these things in the past. It would be very difficult to change anything here because of the physical separation, the physical way the data cannot be changed. So that's append only. And this is the way it would work. Okay, I've created a schema. I created a table called keycard events. The keycard events just keeps track of what employee, think of it as a badge, an employee assigned to the badge, what operation happened and when did it happen? So these are normal create table statements, and you say with ledger on, and you can state it to say and make it append only. The default is append only if you create a ledger table, but you can also specify it. So you can see the design factor is really easy here as long as once you have deployed the database to have ledger tables and set up the secure storage. There are also append tables, and what's different about an append table is you're not really appending it. SQL Server just makes it look like you are appending the table, and that's so that you can run queries, that you already created that can update tables. So an updatable table has both the same things, the ledger table, the ledger view, but it also has a history table, much like a temporal table, because we think it's based on temporal table because it has the same constraints as temporal tables in SQL Server, which I think I don't know when those were introduced. I think 2016, but definitely have been there for a long time. The updatable table, I'll show you in a screenshot, but basically the updatable table acts almost like general accounting principles. You're not really updating something, you're creating you're saving the old value and inserting the new value into the ledger table, but the old value is over in the history table for sure. And the same blockchain, the same ledger, the same digest, the same trusted storage. And this is a real benefit because when Oracle introduced their blockchain tables, they didn't have updatable tables. So you could only use their Oracle blockchain tables as append only. So that was interesting. So the syntax for creating a table, this is like accounts. So you have all this, but you say you say ledger on, but you say system versioning on, so that it allows you to update the table and keeps track of that history table. And it goes off and creates the history table all on its own when you do this. So some key features, key takeaways for ledger tables is you can have both databases and tables. A ledger database just says all the tables in it are ledger tables. I think that's I can't imagine I'd be in a scenario where I'd want that unless I had a very special application that I was building the database on. So I would probably just designate certain tables as ledger tables. The database digests are the things that are kept in that secured storage outside of SQL Server. The DBA can't get to them. Tables can be updated or append only. You want immutable storage for those digests. Immutable meaning cannot be changed. This is a common term used in blockchain, that the storage is immutable. And then you have this feature of ledger verification. So I'll show you that in a second. So in this particular grid, we had Nick Jones had a balance of 50, but we updated it. Oh, wait, which way did we do it? Yeah, we updated it to 100, and you can see down here in the history table that it says that we deleted the 50 from the ledger table and inserted it at 100. That was an update. The query looks like a regular update query, but under the covers, this is what happened in the history table. Deploying a ledger table, it's a property of a table at creation time, like I showed you in the DDL. You choose whether it's updatable or not. Deploying a ledger database, you have to do it at creation time, and all the tables are ledger tables. Can you change an existing table to a ledger table? Nope. You have to do what we don't call it this typically in SQL Server, but in other databases, we call it an extended alter. These are the types of alter statements that you might be, that might have to happen. Like, if you alter a table and change the order of the columns, you can't do that in a relational database. You have to create the new table, copy the data from the old table into the new table, and then clean up the old table. So in the rest of the world, we call that extended alter. I'm trying to get SQL Server crowds to use this terms as well. So it's kind of like a little mini migration. So we've had to do this in the past. So just know that if you have to upgrade a regular table to a ledger table, you're really creating a new one, moving the data in and getting rid of the old table and hooking up the new table to everything else that it used to be hooked up to, if that makes sense. So where does this information get stored? It gets stored, of course, in sys tables, because these are properties of sys tables. I'm not going to go through this, but just know you can find out whatever your tools you use. Like if you don't use SQL Server Management Studio, if you use DB Artisan or some other third-party tools, if they can read these sys table things, they can also know which tables are ledger tables. And then the final thing I wanted to talk about in this is that you can now, remember I said, you can ask the database, you can ask SQL Server to compare the table to the digest in the trusted storage, and it will go verify that nothing has changed between those two. And it can say ledger verification succeeded. It's actually a query, a select, SP verify, a stored procedure, verify database ledger from the digest that it's stored in this location. So one of the hacks for this, for people who have access to both, is to change the location of the digest where they've populated the digest with the altered data. It can be done, and this is why you shouldn't let the same people or the same accounts have access to both the database with ledger tables and the trusted storage. So why would you use it? It's more trustworthy. We've done this before by, I mean, traditionally, the way I did it in the old days is you created a history table on your own. Every time you made a change in the base table, your application wrote it over to the history table and you kept track of the history. Then we got temporal tables to kind of do that. But what's new here is that addition of separate trusted storage with no access, that it would be almost impossible to tamper with both of them. Here's an example of the DBA skeleton that PowerPoint. It really is, I mean, hackers can do all this, but this is also a protection for insiders. So people with elevated access to the database still can't tamper with it because they can't tamper with the ledger itself. And this is also beneficial if you want blockchain-like functionality, but not all the overhead and the performance problems of deploying full-on blockchain. And you get to do it all right inside of SQL Server. Any questions about this? Has anyone heard of it, played with it, looked at it, seen a demo of it? Does anyone think they might use it as well? Okay. So I'm going to blast. I'm going to kind of blast through this because this is brand new, recently announced in preview. There's been Azure Arc for a while now. Azure Arc is a way of connecting Azure services to on-prem servers and devices and infrastructure. That's been around for a while, but recently introduced was Arc-enabled SQL Server. That's the official name of it. That allows you to connect some Azure services into your on-prem SQL Server databases or other scenarios that I'm going to go through that are like running your own SQL Server, like the Box product. And you can learn more about this, but it allows you to use some controlling policy, inventorying, and data classification of your on-prem stuff. So I think Microsoft's going to have a big push because, you know, when cloud services first came out, the cloud proponent people were like, on-prem's going to go away in a year. Like, for any of us who have been around for a long time, I mean, I cannot tell you how many times I have been told relational databases is dead, long live relational databases. And here we are, relational databases are still being used, not for all data workloads, but still being used, right? I mean, I started working with databases in the pre-relational era, have lived through all the relational is going to do away with all the other database types, and I still have clients that use IMS. So yeah, and we won't need DBAs anymore. That's my favorite. And I went through that even in the pre-relational days, that relational was going to do away with DBAs, and boy, were those people wrong. But the things that Arc-enabled anything, like Arc-enabled anything on-prem, SQL Server, the SQL Server part of that is just introducing a small set right now of what it supports. So Azure Arc has dashboards, best practice assessments. It's also going to allow you to use Azure Active Directory, what's now been rebranded as Entra, to do authentication against your on-prem SQL Server. So that's been something that people have asked for before. And now if you enable Arc-enable SQL Server, you can now use Azure Active Directory for authentication into your SQL servers. It allows you to bring Microsoft Defender for SQL Server into your on-prem databases, a little bit of Microsoft Purview. I'm not going to get a lot into Purview, but it's their data governance, data protection, a whole bunch of things, and data cataloging to Azure. But now you'll be able to use some of the features on your own. And you can also bring on your own pay-as-you-go SQL Server, which I am not going to talk about licensing or pay-as-you-go. So this is just a bigger slide of all that. It means that on your on-prem SQL Server servers. You'd have this Azure Connected Machine agent. Or sorry, that's for Windows, but you'd have an Azure extension for SQL Server that you'd run in SQL Server and on your SQL Server servers. And then also, if you wanted to use Azure Monitoring, which I'm a big fan of, you could install that and it would feed your event log and your perf counters, other metrics back up into Log Analytics, which is part of Azure Monitor, and also bring advanced threat protection and vulnerability assessment into SQL Server. So an example of a SQL Server inventory by having installed Azure Arc for Azure Arc enabled SQL Server. I know they're going to change that name just because it's so hard to say, but maybe. Where you could do inventories, what versions you have, the count of databases at by compatible, like dashboards. You know it's a dashboard because it has donut charts in it, which always makes me want donuts. You're going to ask me, what versions of on-prem SQL Server does it support? It supports Windows Server 2012 and later, some Linux versions, SQL Server running in containers, failover clusters, all these things. I'm not going to read it all out, but it also supports SQL Server running on a virtual machine in Azure. It also supports SQL Server running on VMs in other clouds like AWS or GCI. Any questions about that? There are a lot of presentations, a lot of stuff in there. Mostly what I want to bring is there are some security privacy features that you can also bring in from Azure to your on-prem SQL servers. Couldn't go into a lot about this. So here's another task that you can do in SQL Server Management Studio. You can right-click on a database, go to Task, go to Vulnerability Assessment, and scan that database for certain vulnerability assessments. And I'd like to hear in the comments if any one of you has ever done this, because I think it's a riot to do this. By the way, any of these assessments I'm showing are off my test databases, not off anything in production. But you can see in this one database that, okay, the database owner information in the database should match the respective database owner. This is surface area reduction. It's a high risk. DBO users should not be used for normal service operation, and TDE should be enabled. Notice all the shoulds. So here's your number one reason you want to run this both in SQL Server Management Studio and any vulnerability assessment that's available in Azure for your Azure properties. And that is because an auditor is going to come in and do this. A new consultant, these are the worst ones. A new consultant is going to be brought in to help you with some performance tuning things. And if they work for a certain type of company, they're going to run these vulnerability assessments on your database. And then they're going to report to management that all your DBAs are idiots because they've let all these vulnerabilities hang out. So there are two reasons you want to run these. You want to run it because you love your data and you want to protect your databases and your data. And the second reason is you don't want anyone else running it and reporting the results out of context. So for instance, that last one here, TDE should be enabled. A really bad consultant's going to come in and say, none of your database is encrypted when you might have encryption at another layer, say at the server level or at the storage level, or you have a third-party tool that does it or something. These vulnerability assessments are Microsoft's best guesses of what are good practices. Yeah, everyone should go run these tonight, maybe tomorrow morning before you go for your 5-mile jog. I don't know, but you should be running these against your databases. And like it gives you these things. You can configure the baselines. The other thing you can do is log something that you address. So let's say it found this vulnerability. You could totally log this as We don't use TDE because we don't triple encrypt our data for these reasons, or we use a third-party thing, and that will go away from your vulnerability assessment. Now, of course, some people go in and fib and just say, nope, we're not vulnerable, we're not vulnerable. But if you do that, there'll be a record of that, and that would probably be a career-limiting move, my guess. Yeah, I love showing this thing. Then there's Microsoft Defender for SQL, and I'll tell you where this runs. Definitely, because it's an Azure service, Azure SQL DB, Azure SQL Managed Instances, dedicated SQL pools in Azure Synapse, formerly known as Azure Data Warehouse is what that is. SQL Server running on virtual machines in Azure. And now, because of the Arc-enabled SQL Server, you can run Microsoft Defender against an on-prem one running on Windows. Right now, you can't run it against Linux, SQL Server running on Linux on-prem. That's one of the constraints. Also, if you have Azure DB for Postgres or for MySQL or for MariaDB. How does this work? You get security scores. And again, the vulnerability assessments that Defender uses looks just like what I showed you that's available in Management Studio. They are separate services. They have a lot of overlap, but the Azure one is going to be much more complex and much more up to date. And you can also run certain compliance checks. And, in case you have, FedRAMP and all these other compliance things, you can run compliance checks against it. But the reason you want to run this is even more than the vulnerability assessments in Management Studio. Oh my gosh, an auditor is going to come in and go check your security score. Now, the security score is a very contentious thing because it's a score that Microsoft calculates based on all those vulnerabilities. And we know that how they check, what they check, couldn't possibly check on everything. And there's a lot of debate about whether something is actually a vulnerability, whether it's just informational, or what the risk levels are. Your answer to any of this of should we do this is always going to be it depends in the real world. But the vulnerability checkers, they're just sort of a baseline brute force thing. Still have learned a lot about securing my databases and tables using these. But this bad consultant or this auditor is going to go run this against all your Azure and all your Arc-enabled ones. And imagine if they went to your CIO and said your DBA's security score is 58%. And you should hire all of our DBA consultants and fire all your on-prem ones. I've seen this happen so many times, and I know consultants who regularly do this in the SQL Server world because most on-prem SQL Server DBAs haven't heard of these things and aren't aware that these numbers exist and scores exist, especially in Azure things. But now that Arc-enabled's done, someone could come in and send your logs up into log analytics and get a score. So the secure score, again, it's contentious. It's not real because it has to be done in context, and it's based on practices and your progress against them and Microsoft and industry best practices. But we all know the answer is it depends. And if you've never gone in and said, yeah, the reason this database has this terrible security score is we use it for training on our new DBAs. It's a copy of AdventureWorks. See, this is why my score here is so low, because these are intentionally designed databases to have vulnerabilities. So you'd be able to document that there. So the other thing about Microsoft Defender for SQL Server is it gives you tips on how to remediate or fix or apply a policy. It sometimes even pops up the code you'd need to run in order to close that vulnerability or address it. And it also allows people to measure their progress towards addressing all these vulnerabilities. So a typical endpoint is that, for instance, this is one Azure SQL database. It's one I run. It doesn't have a private endpoint. It has a publicly endpoint. Anyone with the right credentials on the internet, can log into it because I use it for training, and it's only an AdventureWorks database. There's no risky data in it at all. And it still makes me feel bad every time I see my score. Azure Monitor is a service that is a combination of services that used to have different branding, and it basically allows you to collect logs and metrics events that are happening with SQL Server, and allows you to see dashboards of it and to get alerted if they exceed certain properties or anything. I really like this. I think a lot of you guys have third-party tools to do it, and that's fine as well. But if you don't have a budget for third-party tools, maybe you have some Azure budget where you can start monitoring your Azure SQL Server, and even now some on-prem stuff if your SQL servers are ARC-enabled. So here's my thing about security and privacy. Which one is right or most important for you? I mean, I love my data. I want all of these things to be important, but because I'm not on call, because I'm not responsible for performance issues, I'm going to put query performance last. That's because I'm measured, compensated, rewarded, and punished based on data quality and data security, and I am not measured, rewarded, compensated, or published based on query performance. But that doesn't mean performance tuning DBAs and I can't get along and manage to negotiate the cost benefit risks of any of these things. I'm going to skip over this one because it's just a swipe from books online. So I'd love to know what your favorite security features are, even if they're an older one. And I think that performance is really important, but I think making bad or tampered with data go faster doesn't help the business at all, because every design decision comes down to cost, benefit, and risk. Oops. And I have this last poll. What features that I've talked about today might you look at next? So again, go to slido.com, put in that number, and you should see this poll being active. I expect at least one addition here. Oh, someone's typing. Row level security, good. I like that one. Always encrypted, yep. See, someone was taking notes. This is good. Enabled SQL. Like, I'm going to go play with that next because I'm doing a presentation about that soon, and I got to figure it all out. Okay, so it's funny you mentioned Past Summit, and sorry to mention, so the week of Past Summit, SQL Server Live, and I think at night, Ignite are all the same week. I know there are 3 big conferences, all the same work. Tom LaRock and I are doing a hands-on lab about all of these topics and more, as you can see from there. So this is one of your other options to come to a conference that has multiple tracks. I hate talking about competing conferences, but because I'm speaking at this one, I'm just putting a shout out. All hands-on labs are so much fun to do, and I'd love to see you do that. Oh, and they've added a new track for cybersecurity and ransomware in case you're especially interested in this. So one more time, every design decision comes down to cost, benefit, and risk, and I want you all to go out and be great and design secure databases. And I'd be happy to take any other questions or comments now in the chat, but I would prefer if you came off mute.
Well, because I'm a slow typer, I didn't get a chance to mention my favorite feature, and mine is happens to be TDE, and it's something that I recently learned about and put into practice where we work, and we're still doing that. So it's my favorite because I just learned about it.
So that's good. And that's been around forever. So it's good that, that we're doing this. I mean, I'm a big fan of it as well. In fact, when you go to deploy Azure SQL database, so SQL Server as a service in the cloud, TDE is on by default, and they've made it even harder to turn it off because they think encryption is so important.
It is. It's very important. Now, the reason that I've never adopted it at our place is that I was told, well, we've got it's encrypted at the
Storage level.
storage level.
Yeah.
Thank you. And that's great. But the thing is that somebody could steal a database backup.
Yep.
And restore it on their desktop version of SQL Server.
Yeah.
And away they go.
Yeah. There's that. And then there's the fact that even if you have encryption at the storage level, if someone has compromised the storage, they've compromised your database. And there is an overhead. So I can remember the days where I was told we couldn't encrypt our data because it would hurt performance. Because every time you encrypt or decrypt, that causes compute pressure, right? We all know that.
Yeah.
Every design decision. But it wasn't until there started to be a lot of civil penalties, a lot of privacy legislation and compliance legislation just say your data has to be encrypted, right? It doesn't go out of the way to say how. Well, TDE is a fast way of doing it with some overhead, but because you're required to have encrypted data, it's an easier way of doing it, right? So it meets that compliance need. And you don't know, like you said, someone takes a backup, they can restore it onto, if it's not encrypted at the SQL Server level, they can restore it onto another SQL Server and you just go at the data because it's no longer on the storage that was encrypted. It's now on my laptop, and I've also left it on a train. So not only did I get access to the data, the next person on my laptop gets it too. Or I put it in an open bucket on S3, one of those two.
Yeah, absolutely correct. Yeah.
So yeah, that's a good one. I'm a big fan of, I literally can remember the days arguing that we can't afford to have encryption. How crazy that was.
Yeah, well, times change.
That's it. And that's why
we must change with them.
Yeah. So I hope I've inspired you guys to go look at these things. I feel like a lot of the speakers and the bloggers in the SQL Server world, because they don't do what I do, because they're mostly performance tuning, performance operational DBAs, that they've kind of gone, oh, okay, I don't need to know about these. But I love talking about these topics because it might not be the right solution for you, but at least you know it exists. And it's free inside of SQL Server because these are inside the database. Everything I've talked, except for the Azure Arc stuff, everything I talked about is in all editions of SQL Server, right? These are what Microsoft tends to do, licensing based on if it's a programmability, which they include designing tables as that. It's part of standard edition or web edition. I can't even remember all the editions that are available. So that's the other good reason to use them. They're not just an enterprise edition.
Yeah, definitely. I was going to say it's really helpful what you talked about, because at my previous company, I remember I was trying to create a centralized database for a couple of different departments, and it would have saved me so much time if I had known about row level security.
Exactly. Like it and again, if you do it in the database, then anything that connects to the database gets that enforcement. That's the brilliant part I like. Is you don't have to create views and other objects or write code or check. I don't know. I don't even know how people do it nowadays, except in an application of some sort.
Yeah. Exactly.
Or they create separate databases for everybody, which never works out in the long run.
Yep, that was what the route I was taking at first. It's unfortunate.
Yeah, and you could have created views, just a bazillion views, right?
Yeah, exactly.
Excellent. Well, if you ever have questions, oh, by the way, I was going to say, like, I am on Twitter, trying not to use it much anymore. But on Blue Sky, I'm Data Chick. On Instagram, I'm Data Chick. I'm Data Chick everywhere except LinkedIn, where I'm just plain old Karen Lopez. But there are a bazillion Karen Lopez's. But if the URL is LinkedIn/in/Karen Lopez. So if you want to link with me or friend me or whatever, if you mention we met here, I can process that faster. And I always love engaging with attendees. And Mastodon too, as you can see there. Excellent. I always like positive feedback, but I also like, well, it's called critical feedback. I call it contribution feedback. How could I make this better? And I know I could make it better with demos, which I do have, but I tend to do the demos when I'm only talking about one of the features. Everyone, make yourself a note. Tell your virtual assistant to remind you tomorrow to go run vulnerability assessments on your SQL servers.
Oh, definitely.
Just to see what it does. So that's all I have.
Well, thank you, Karen. That was a terrific presentation, and I learned a thing or two.
Thank
So,
you. I love hearing that because
I may
I'm not a
look smarter,
DBA.
but I am smarter.
I appreciate that. So everyone have a great evening. Thank you for everything. Thank you for your questions. Thank you for your comments. I appreciate them.
Thank you.
Thank you. Bye, all.
Bye.
Bye.
Bye.